Craig Scanlon. I'm a research officer with the Department of Agriculture and Food in WA, and we've been investigating the impact of changes in soil pH after lime application on how the grain yield of crops respond to fertiliser application. And overall, we've found that changes in soil pH have the greatest effect on yield response to phosphorus fertiliser, followed by potassium in terms of order of magnitude, followed by nitrogen, then micronutrients. So with phosphorus in general, we find that an increase in soil pH has the greatest effect on yield at low rates of P, in that the difference in grain yield between an acidic and a treated soil at a low rate of P is higher than the difference that you would see at higher rates of P, say out at 20 and 25 kilos of P. So really, the applied outcome of that is that under acidic soils, when your soils have pH, say less than 5, particularly less than 4.8 or 4.5, that grain yield is highly sensitive to P rate, and as you increase soil pH, grain yield is less sensitive to P rate. With potassium, we have found at higher rates, say up to 5 tonnes per hectare, that lime has displaced potassium in some cases, down as far as 40 centimetres, but it's not really changing grain yield response to K, except in one case where 2.5 tonnes of lime was enough to increase cation exchange capacity and actually increase Colwell K in the surface. So that increase in Colwell K that led to an increase in grain yield lined up pretty well with current critical levels. We've also done a bit of work on soil inversion on water repellent soils to examine how that changes the residual value of phosphorus and potassium fertilisers over a 4-year period, and we've actually found that grain yield is basically insensitive to phosphorus and potassium management at that site, and it is far more sensitive to early seasonal conditions, particularly rainfall during autumn, which affects the yield response to soil inversion. So we do see a yield benefit from soil inversion when we have dry conditions in autumn, and we've seen no benefit from soil inversion where we've had wetter conditions on a water repellent soil.